Hello everybody. So it's 1:30 already, so let me introduce Maciej Szulik, who is my colleague from Red Hat and works on OpenShift.
Hi. So as Radomir mentioned, I'm working on OpenShift, and I'll try to guide you through how to run microservices on OpenShift, or generally speaking, any kind of Python-related application. You can find me online at Soltis, whatever. And I was doing last year a presentation, Journey to the Center of the Asynchronous World. Is somebody on the audience that's seen that presentation by any chance? Okay, one person. That's not that bad. I hope that it wasn't that boring that nobody else seen it. And as Radomir already mentioned, I work for Red Hat with a bunch of crazy people, and we call ourselves the OpenShift team. But it's fun. There are two topics that I would like to cover today during my talk. One will be the microservices, and the other one will be OpenShift, and in the end I'll try to join the two. So let's start with the microservices. Microservices are cool, and just like the bus slide here says, they are everywhere. And that's pretty much true how it's done. I know that Woody is a little bit disappointed, and probably most of the managers and some developers are as well, because we're moving from big monolithic application to lighter, more agile development process. I won't be covering the details, the specific details of how to write microservices. There are pretty good presentation online already, state of the art in microservices by Adrian Crockford, Martin Toller's Microservices, the entire section on his website, and there's a colleague of mine, Stephen Posty, that did a microservices and a practical introduction on during this year's DevNation conference in Boston. If you follow my presentation, the QR code was a link to that presentation. The three of those are links, so you can follow those and have a closer look at it. So the general takeaway from the three resources are that microservices are loosely coupled applications with clear boundaries. What does it mean? You have small applications, each of them is well defined, each of them has a clear boundaries, clear API interfaces. You define how you communicate with the rest of the world. And that's what you do, and there's no way that you can mess it more or less. Microservices approach is that we're moving from big monolithic application where everything, like entire application was in one big code base. We're moving forward to smaller application where there are small parts responsible for a single event, for a single action, and that also allows us to split the development process, meaning that the teams can move on each team can move forward on its own. Where with that I mean each team can have either even different sprints with this. That's what I said, just independent sprint teams. And most important, the microservices approach is technology agnostic, which means that with different sprint teams, you can implement different technologies, meaning that one part of the overall application will be written in Python, the other one will be written in JavaScript, or one other in Rust, or any other language that you feel that the team feel comfortable with. But as always with any approach, it's not for all applications. So choose your tools wisely and always see if that actually fits your solution, because it's not good to try to force certain approaches when it doesn't make sense. Okay, I wanted to come up with some nice example, so I decided to create a new Google. My new Google will be called The Blast. I just come up with some fancy name for it. And my Blast search engine consists of 3 backends. One will be responsible for searching text, the other one images, and the third one videos. And there's a UI with HTML, JS, CSS, and stuff like that. So generally speaking, we have 4 services. Each of the services is responsible for one particular thing. The UI, as obviously, is responsible for presenting the results to the user. The backends, each one is independent on the other one. That also means that if one fails, the Blast UI should proceed and just ignore or doesn't show the results from one particular backend. Well, I need to start with something. So. Okay, if you would like to deploy such an application in the regular Python world, meaning with some kind of a web server that will be usually backed up by some WSGI container, be that mod WSGI, micro WSGI with engines, or the previous one with the Apache server, or GUnicorn, whatever. And there will be a DB. And in front of that will be usually a web server where the UI part will be sitting, and in most cases the web server will be also, or might be a kind of proxy for the entire deployment. But that feels hard. There's a lot of risk and a lot of challenges to cover that. What we would like to have is independent deployment of each of the parts, meaning that I would like to independently deploy each of the blocks that I have on the previous image. I would like to simplify the management of each of the deployments as much as possible, and in a way that I can independently manage each of the deployments. It should be easily scalable. That's pretty much obvious. We will probably need more resources for image processing and video processing than for text processing. It has to be secure. That's obvious. I don't have to talk about it. Laura's already gave a great talk regarding security, so I want to repeat myself. I would like to introduce you to a phrase that is being very recently introduced that tells about pets versus cattle. Did some of you heard about pets versus cattle? A few, okay. So a quick recap for the others. Pets versus cattle is about how you treat your servers. We generally treat our servers as pets, which means that we take care of them. If they fail, we take care of them as with pet you would do. You give them meaningful names. You take them to doctor if they fail, so that's what you basically do. And you usually try to recover if they don't work the way you do. But what happens with cattle? The cattle, if it's sick, you shut it down and replace with a new one. And that's what you want to do with your servers. Your server is supposed to be independent enough and unchangeable enough that you can easily deploy it once again without being afraid that your deployment, your redeployment, will change will change the behavior of the application. And that is phrased in the self-contained as well. Okay, so how would you want to have your application being a self-contained? That means that I want to have the entire application with all the dependencies within one thing. Let's call it a thing for now at least, until I introduce the other terms, where the thing will tell you how to run it, what does it give you, and what you can expect from it. Additionally, provide some configuration options to a little bit, at least, configure it. But generally speaking, you do not want to modify its behavior in such a way. Okay, but when you have those things, let's call those things images, because I don't like the word things. When you have tons of those images and running, then you need a mechanism to orchestrate those. And if you talk about deploying not 1, 2, or 4 services like I did with my example, but when I'm talking about hundreds of hundreds of images running one at a time, you need a really decent mechanism to orchestrate the entire thing. That orchestration mechanism is provided with Kubernetes. Does anybody heard about Kubernetes? That's cool. That's very cool. Does anybody use Kubernetes? Tried Kubernetes? That's awesome. There's a few, but I'm very proud of seeing that there are folks that tried already the Kubernetes. So Kubernetes is a project started by Google, and who knows better how to run millions of containers than Google, especially that they just recently, a couple months ago, released the doc explaining how they internally are running millions of containers per day. The system they are using internally is called Borg, if you want to read it for that. But Kubernetes is a new project. It was started last year, more or less. It's written in Go, and I'll probably talk about it in a minute more. Yeah. So that's pretty much enough to know that it's written in Go. Oh, we're on a PyCon conference, so Go doesn't matter here. So what does it do? How the Kubernetes looks like? There's a master that is responsible for actually scheduling your containers. A running image, meaning a running image. So the thing that describes how your application looks like is called a container. So containers are placed on nodes, and the entire thing is scheduled architecture by the master. The master takes care of the authentication and authorization. It provides the REST API that you communicate with, so that you can actually schedule a job or a process to the Kubernetes. And it keeps everything in a key value data store that is called etcd. Who has heard about etcd? Okay, not that many, but pretty much the same that heard about Kubernetes. etcd is based on the Raft protocol. Who has heard about the Raft protocol? Same people. Okay, so in 30 seconds explanation, Raft protocol makes sure that there are always majority of pods running, and they are able to elect some. The majority is able to elect how the replication is handled within the etcd deployment, more or less. Very fast and very reliable. So we have the master that is responsible for scheduling, and then we have the nodes. Nodes are the actual workers, meaning this is where your images are run. On each of the node, there is a kubelet process. It's a process that is communicating with the master, and it's being told how many or how your containers to run. The containers are grouped in pods. A pod is the smallest unit in Kubernetes. It allows you to actually run your image with your application. And the general idea is that the pod can contain multiple containers in it. For example, you can have one container responsible for your web application and the other one responsible for monitoring. Although you can mix it with, for example, with your backend. But the general idea is that you usually would want to have a pod representing your application and eventually some diagnostics, because the analogy about cattle and pets is that Kubernetes takes care of pods as cattle, meaning that if one pod is failing, it will kill the entire pod, replacing it with a new one. So usually you would not want to mix and match a web UI with a backend, more or less. I'll show you that in a demo in a couple of minutes. Maybe you'll get a better understanding. So key concept, as I mentioned, the pods is the smallest unit in Kubernetes. The service is a one level higher primitive that allows you to group pods into services that you can then expose externally. The label is a grouping primitive for Kubernetes, meaning that each pod, each unit, each resource in Kubernetes has a label on it, and based on those labels you are able to group resources together. For example, there is a controller that is called a replication controller. Its responsibility is to keep that many pods that you want of a specific application, of a specific image. And this is done with labels, meaning that if I describe my replication controller as my superservice A, and I want to have 5 pods running of that replication controller, that means that there will be 5 pods with labels my superservice A. If there will be more or less pods that will be selected with that label, that means that they will be either killed if there will be too many, or if there won't be enough, then there will be another one created for us. And the namespace is another a grouping primitive, more of a project namespace, something like that. So okay, from Kubernetes, on top of Kubernetes and Docker, which is used for running the images, which is the mechanism for actually running the images that I didn't talk about before, there is OpenShift built on top of that. But if you paid attention to what I said to Kubernetes, you might wonder, why do we need something more out of Kubernetes if Kubernetes already provides us with all the mechanism for running the pods? So, a quick recap, what's a OpenShift? OpenShift is a platform as a service. Who has ever used OpenShift? Oh, that's cool, a couple of those. For those who have not, OpenShift is a platform as a service written by Red Hat, and it's open source. Generally speaking, you provide us with a source code, and we provide you with a platform to run your application. The biggest deployment, one of the big deployments that we have is OpenShift Online, where you can actually go out and try how OpenShift works on your own. I highly recommend to give it a try. So the general flow is that you code your application, you bring it to OpenShift, and we run it for you. And this is what we want to maintain with Docker, with Kubernetes, and that is the OpenShift v3. So the add-ons, the additional thing that OpenShift introduces over to Kubernetes are the builds As I said, you provide us the code, we provide you with the environment to run this, but we also need to provide you with the environment, with the infrastructure and environment to build your application from source. Because with Docker and Kubernetes require you to have that ready image. But if you're a developer, you're also interested in actually transforming your source code into a running image. And we do that with a source to image project, S2I. Or if you are actually interested, you can actually write your own Docker files, and there is a Docker build strategy as well. We provide you with deployments. Deployments are, generally speaking, replication controllers I was talking before, but with ability to provide you with the rollbacks and allow you to snapshot your deployments at a certain point in time so that you can easily go back to your previous deployment in case your current deployment fails, or providing you with some sophisticated deployment strategies as blue-green deployments, A/B deployments, and more. Additionally, we allow you to define your own deployment mechanism if you're interested in it. One other additional things are image streams. Image streams allow you to track the images that are kept in Docker registries. Because what I didn't mention before is the images produced by the builds. Either you do them by yourself or you use the OpenShift to build images. The Docker images are kept in a Docker registry, and you can use that. For that, you can use either Docker Hub or internal registry that we deploy with OpenShift v3. And the image streams allow you to track those images, the changes to the images, the history of the changes, as well as provide you with a way to, for example, trigger your build or deployment if a new image appeared. For example, a very nice overview is that when a security update is being released, you can trigger a new build, which will produce a new image that you want to run, and that will, again, because a new image was produced, can trigger a new deployment. Additional thing that we also do with OpenShift v3 is project. A project is, generally speaking, a namespace with additional security layers on top of it. Templating mechanism, because if you want to provide some repeatable mechanism to deploy your application, but additionally, you would like to randomize certain things like passwords or certain certificates or things like that, and you want to have random on deployment, you can do that with templates and additional routing layer for the entire deployment. Okay, I'll try to do the live demo right now. We'll see how that will go. I hope the demo gods will be good to me. I have a OpenShift running already. This is the web UI. I have two projects. The default project is the default project is the core of the OpenShift, let's call it that way. If you have a closer look, there is a Docker registry deployed that I talked to you about before. There is a Kubernetes deployed underneath it, and there is a router already deployed there. But that doesn't matter. I have a script that does this for me automatically, because I don't keep that on my own every time. What we are interested in, and we are at the OpenShift 3 sample project. I've created a sample application. As I said, that blast. And you can see that there are four microservices: blast image, blast text, blast UI, blast video. As I explained before, each of this is responsible for that one particular comes from the admin at the end. Let's have a look at one of those. I'll close my presentation because it doesn't make sense. The Blast UI. This is a template for OpenShift. It might seem a little bit complicated. I'll hide this part. Because you would normally stay away from writing the YAML files for those. But if I want to have those redeployable, and generally speaking, you can try deploying the application on your own, I had to create something like that. So let's start with this. I'll create those services in all these objects, and we'll see how that will go. Yeah, I have a script for that is creating tons of objects, tons of resources that I'll try to go through to get you a better overview. So, yeah. Let's start with the builds. I have 4 builds that I defined. Each of those builds is for one of the microservices. There's even information from what repo is being built, and we have the information that all 4 builds are running. It will take them some time. It needs to get each of them needs to get the source from the repo. I hope the venue Wi-Fi will allow me for doing that. Worked a couple minutes ago. Usually it was about 2.5 minutes for doing that. So how one of those builds look like actually. So the build is from a source repo at my top that I just showed you. It's a simple Flask application that does nothing more than connect to a database behind it and return a REST service with the information either on images, text, or videos that I provided with some information. And I'm using the source build strategy. As I mentioned you before, there are 2 build strategies. One is the source, meaning that I provide you with a source, and the OpenShift will take care of transforming my source into a actually running Docker image. The other one is that you provide a Docker file as a GitHub repo, and from that Docker file we'll create a running Docker image. The output of the build will be pushed into test/blast image. Test is my project name. I can configure GitHub webhooks or generic webhooks. This is done to automate the build process. So for example, if you push some changes to your GitHub repo, the build process can be notified and the build can be triggered on their own. There is config change for the build, which allow you again trigger a build when actually the build config will change, or you can actually manually start the build. Let's have a closer look. Okay, all 4 builds finished successfully. That didn't happen to me in a while. The couple times I was doing that, every time at least one of the builds failed. But let's have a look at the console, because most of the things that we usually do with the console. I have the builds, and I can see how the builds are actually run. I can see the logs from the builds. Yeah, we see that at the end, the Flask RESTful, and all those dependencies were installed, and the resulting image, blast image, was pushed into Docker registry. Yeah. Okay, so we have the build. The builds are done. The next things are the deployments. We should have at least 4 deployments plus additional 3 for the backend databases, as you probably remember from one of the images. Each database has its own deployment, and each microservice has their own. So there are 7 deployments actually happening. All of them are running. That's very good. One is for blast image and the backend blast image DB, and for the rest. So what is a deployment? A deployment describes you similar to what a build config is for build. This is the same build config is for a build for deployment. It describes you from which image, how many replicas we want of that, and what kind of a deployment strategy will be used. For that, I have what kind of a label the pods will get when being created. I have one replica of the blast image microservice. It is using rolling strategy for that, and you can eventually start the deployment if that failed. The image streams, as I said before, are there to track what happened to your image in the history. Since I just did the build, there's information that the latest tag was pushed about 4 minutes ago. There's a full spec of the image that you can use for the deployment. There's tons of technical information in it. If you're not interested in it, just skip those information. The pods. So I didn't do something fancy, at least as of now. So there should be the same amount of pods running as deployments, meaning 7, because each deployment runs just one replica. Additionally, there will be 4 build pods that just finished they're doing their job. There are routes defined for my application and services. Let's start with exploring actually my application. I'll go to the UI. That looks fancy there. And let's start searching for something. And so that I'm not lying, actually, I'll do a network preview that it actually is reaching. Okay, I provided the application with some initial data so that whenever you search for OpenShift, it will reach those 3 backend services, as you can see. We're reaching, is it possible to extend that one? No, it's not. We're reaching the blast text, the blast image, and the blast video. And these are actually some presentations that happened on the OpenShift. Yeah, there's some 0 to fast. So that's more or less how this looks like. There's some information about my photo. That's pretty much how the OpenShift works, and then very short term. That's pretty much what I have for you for now. I would be happy to answer all your questions. If you're afraid to ask them out loud, you can always find me. I'm on the conference till Sunday, and I'll be able to help you with all the questions or doubts you have with OpenShift.
Question raised your hand.
I was almost afraid to say that all my presentations are so hard that nobody has any questions.
I've got a question about availability. Do you have any kind of fate sharing rules and stuff like that on the OpenShift level? Like preventing from pods from appearing on the same hardware, for example, so that when one server goes down, you don't have to worry about the whole application?
Generally speaking, if the node goes down, you don't care about those at all, because this is how Kubernetes works those out. it will count how many pods are actually running, and it doesn't matter how many nodes you have there. So if one node will be killed, and that will also kill your application, that will recreate your application very easily. I can show you how the scanning works. It's just magic, but very cool looks like. And on the other hand, yes, there are options to, now I'm using the proper word, to split your deployment across the entire infrastructure.
Okay, thanks.
In terms of size of or complexity of this platform, is it a fairly lightweight solution, or is it fairly heavyweight, or how would you describe that?
Super heavyweight. The Kubernetes project itself, it's so complicated. There are so many things going on, and it is the development process is so very rapid. You can expect about 100 or up to 200 active PRs per day going on, and on top of that, we as Red Hat are one of the main contributors to Kubernetes, obviously, and being part of the OpenShift team means that you take very active part in both communities. Both of the projects are on GitHub, so you can easily follow them. Kubernetes. I was actually submitting a PR just a couple minutes before the presentation with a cherry pick to the version 1.1 because I was working on the jobs. What I didn't say before is that there are two main types of running images in Kubernetes and in OpenShift. One of them is the replication controller, which means that you have your image, your pod running indefinitely, and the replication controller will take care that your image will be always run on 5, 10, or how many specified pods. But additionally, there was a need to actually run images to a completion, something like to a completion. That's one thing, because what I'm thinking about is the other thing. The thing is the thing that allows you to run your image to a completion is a job, and the job is mostly shepherded by me as part of my day job.
Thank you. Now that you mentioned that it's super heavyweight, how difficult is this to deploy if someone wants to use that?
So it's much easier to deploy OpenShift than it is to open Kubernetes. Kubernetes is very complicated. It is designed to be run at a scale, whereas OpenShift is designed to be very lightweight to give it a try, but you can actually deploy very serious deployment with it. I can show you my scripts that I have for running OpenShift. It's not that hard, and these are actually on my GitHub profile. So running a OpenShift is one binary. It's about 20 or 30 gig max around. We can check that one. Yeah, so it's not that big. I want to count that down. Okay, so I lied a bit. It's 94 max of everything, and this is the entire OpenShift with the client binary in it. And you just run it, and you can run it on bare metal, you can run it on a virtual machine. There's even a Docker image that you can run OpenShift with it.
Fantastic, thank you.
If somebody is having problems or would like to run their own OpenShift, I can help with that as well.
Can I ask a question, because you said that Kubernetes is young project.
Yes, it's very young project.
younger than OpenShift. In the previous, you must have you had some tools, some solution to do something that is as Kubernetes do now. Yes, is easier working on Kubernetes or your previous solution?
From my point of view, it's easier to work with Kubernetes and the current solution. It's the architecture is mainly microservices-like, not entirely, but it's very towards to what microservices have. It was very hard to deploy the OpenShift v2. There were too many components and too many things that you need to remember to deploy. And with the new OpenShift and Go, it's very simple to write the application itself. It's faster, and the Go language is much more efficient than the Ruby that we use for the V2.
For you, of course, I understand.
Okay. If I may ask, I would like to ask if using the OpenShift origin distribution, the open source one, are there any disadvantages towards using the enterprise, or do we losing something if I like to implement the origin in a big scale corporation with their own administrator stuff, etc.?
So yeah, my OpenShift is, let's check it, that's not a problem actually. I'm using OpenShift from yesterday around 3 p.m. It has some couple merged, so that's pretty much almost had. Although I bet that there are a couple more PRs merged in the meantime. That's one thing, and yes, that means that I'm running Origin on my machine. And the other question regarding Origin versus the enterprise version, as with every single solution that Red Hat provides, is we provide a lot of stability with the enterprise version that we do not cover in the open source projects. You can, and it will work, but it's not guaranteed that it will be backward compatible with the Origin version that we do upstream. There's a lot of testing done on the enterprise side that is not done on the Origin.
But in terms of the features on the code base, it's more or less the same. Is this correct?
More or less, it is the same, but obviously the Origin project is moving faster forward than the enterprise counterpart, so it will always be a little bit behind. But as I said, the price for the being a little bit behind is the price of stability that we provide with the enterprise solution.
Anyone else? Don't be shy.
I can buy it, and the project is not that complicated at all.
Okay, thank you everybody, and thank you Maciej.
Thank you very much.